Everybody, welcome to another Pulumi workshop. I'm going to wait a minute or so just to see if there are any late arrivals. But while I'm waiting, I will introduce myself. My name is Lee Briggs. I am a community engineer at Pulumi. With me today, I have my wonderful colleague Zach, and I also have my wonderful peers from Amazon Web Services, Andrew and Young, and they will be assisting me today in our public chat. This is a really exciting workshop. We're going to be talking about EKS today, Amazon EKS. If you are here, we would love to hear in the public chat where in the world you are attending from. I'm in the US West Coast in Seattle, and it is 5 o'clock here in Seattle. So if you want to just post in the public chat, like hello from wherever you are, it would be excellent to see where we've got people joining us today. So without further ado, we are 1 minute past the hour, so I'm going to get started. Before we start actually getting into the nitty gritty, we will do a little bit of housekeeping first. In terms of participation, you have the public chat. There is a handouts tab on the big marker panel on the left there. It's also possible for you to participate in our Pulumi Slack. So we have a workshops channel in our Pulumi public Slack. If you would like more help after this workshop, or you want to continue with your Pulumi journey, please feel free to ask us there. The final thing that I'll say is that we are always iterating on these workshops. So if you have any feedback for us, or if you think any of the content was not up to the standards that you expected, we would love to hear from you. We'd love to hear about what you want to learn about. We'd love to hear about whether the feedback, whether the content in this workshop was something that you took away as being useful. So I'm actually going to skip my usual what is Pulumi section and come back to it later. So usually at this stage, I've got the slide in here. Usually before all the people that are attending, if you haven't used Pulumi before, I would tell you a little bit about Pulumi. But what I do want to do is actually kind of get started right away, because one of the steps that we're going to do today is going to take a little time. And so we'll come back to the what is Pulumi section later on. What I do want you to do, however, in order to actually follow along with this workshop, is you will need a Pulumi account. And so what I'm going to very quickly do is guide you through how to set up a Pulumi account. And then I'm going to hand over to my colleagues at Amazon Web Services, who will get you up and running and get you access to an AWS account so that you can follow along at home. So let me very quickly share my screen. And I will pull in the browser. Okay, so in order to actually use Pulumi, you need to store your state somewhere, and Pulumi.com can take care of this for you. So I would encourage everybody who's following along at home to go to Pulumi.com, and you should see the website that you see in front of you. There are two buttons in the top right. There is a Get Started button. Don't click that just yet. Hit the Sign In button. And you should see this page, and it gives you a bunch of sign-in options. You are free to use whichever sign-in option that you feel most comfortable with. I have a GitHub account specifically set up to show you how to do this. So I'm going to click GitHub. If you have a GitLab account or an Atlassian account, or you just want to use your email address, click one of the other buttons. I'm going to hit GitHub. And because I'm already signed into GitHub in the background, it's going to ask me to authorize my GitHub account with the Pulumi console. All we see in the Pulumi SaaS is your email address, and we get some read-only access to your repositories that are in your account. So we don't actually need any write access to any of your Git repos at all. So just verify that you're happy with this. So we've got read-only access here and the email address, and we're going to authorize the Pulumi application like so. And then it will redirect you to app.pulumi.com. and you now have a brand spanking new Pulumi console account, which means that you can follow along with the workshop later. So I would encourage everybody to kind of take a minute to just follow this process. Also, when you create your Pulumi account, you'll notice that there's an organization tab up here. And if you click that, you'll see that the default organization that you have is the same as your GitHub user. So in this particular case, for my GitHub account, it's lbriggs-pulumi. You are going to need this later, so please remember it. You'll need to use this for one of the steps that we do later down the line. At that stage, all of my initial setup things are done. So I am going to hand over to my wonderful colleagues at Amazon Web Services. I think, Andrew, you'll be the one kind of guiding us today through the setup process for AWS Cloud 9. And so I'll hand over to Andrew, who will help you get set up and ready to go with AWS Cloud 9.
All right, thanks, Lee. Hi, everyone. My name is Andrew, and I'm a Partner Solutions Architect here at AWS, and I will be walking everyone through how to set up your environment to follow along in today's workshop. So let me go ahead and share my screen. And so in the handout, you should have a link to the content that we'll be using for today's workshop. And so what I want everyone to do is just go ahead and click prerequisites.
Hey, Andrew. Yeah, there we are. It just took a second for your screen to load, so okay. It's now showing. Yeah.
All right, good. Okay. Yeah. So so I just need everyone to click prerequisites, and then once you see the kind of drop-down menu, go ahead and click add an AWS event. And so what we've gone ahead and done is created a bunch of AWS accounts for everyone to use. And so in the chat, we'll go ahead and paste a bit.ly link for everyone to be able to access their accounts. So let me go ahead and paste that into the chat. So if everyone sees that bit.ly link, if you go ahead and click on that link, it should bring you to this page right here. And so here, just type in your name, and then this will give you access and the information you need to access your AWS account for today. So today, I'll just type in AWS and hit submit. And then once you see that green, just go ahead and click on that link. Then here, it pastes the hash code in for you. So all you need to do is hit accept terms and login. And then everyone should be on this page, assuming everyone was able to get a hash code. So I'll just take a quick pause here to make sure everyone was able to get a hash code to their AWS account. And then for folks just joining, we're on the setup page right now. So right now, we're just getting access to our AWS accounts for today's workshop. OK. And then once everyone is good there, and everyone is on this page, go ahead and click AWS Console, and then go ahead and click Open AWS Console. And so if you're following along in the content page, we are at Create a Workspace. And so make sure in the right-hand corner you are in US West 2 or Oregon. So just double check that you are in the right region. And then under here, we can just type in Cloud 9, because this is the environment that we'll be using to go through today's content. Once you hit this page, go ahead and click Create Environment. And so in the content, we actually tell you exactly what to name your workshop. And so for today, just name it Pulumi Workshop, and you can actually just click this button to copy. Go ahead and click Next Step. And so here, this is really important. For the instance type, we want to use the M5X large instance, just because the workloads that we'll be deploying today require a bit more compute power. So we just want to use a bigger instance size. And then everything else here, you can just leave.
Sorry, Amazon Linux 2 is
has
the newer. Yeah, there we go. It has the newer versions of Go on there. So if you wouldn't mind, thank you.
Yep. And then if that's all good, go ahead and click Next Step. And then before you create your environment, just make sure this all is good. So your name should be Pulumi Workshop. We're using EC2. The instance type should be M5X large. And the platform we'll be using will be Amazon Linux 2. So if that all looks good, go ahead and create environment. Step. Table 1 here. And then create environment. So then this just takes a couple of minutes to spin up. So I'll just take a quick pause here just to let everyone catch up, or if there's any questions about any of the steps we've gone through today. And then in the content, we just finished the create a workspace step for the workshop. So this is spun up properly and everything looks like it's working. So if you go back to the content page, the next step we need to do is create an IAM role. And the reason why we do this is because we need to give permissions to our Cloud9 environment to be able to interact with the different AWS services that we'll be using today in today's workshop. And so with that said, you can just click go to your dashboard to open up another page. And then under services, we're going to go ahead and click IAM. Also, on the content page, there's a deep link, so you can just do that too. Actually, let's just go and do that. And so leave this as EC2, and then go to next for permissions. We want to give our Cloud9 instance administrator privileges, so we'll just leave that as is. We don't need tags here, so you can just leave this blank. And for the role name is really important. And so what you want to actually go ahead and do is make sure that you name your role Pulumi Workshop Admin. Make sure this all looks good. So it's EC2. We are giving this administrative access, and then the role name is Pulumi Workshop Admin. And so if that all looks good, we can go ahead and click Create Role. And then if all that worked properly, you should see Pulumi Workshop Admin in one of your IAM roles. And so if you go back to the content, the next step here is to attach it to your actual workspace. And so if you follow this deep link here, this will take you to the EC2 dashboard. And so what you want to go ahead and do is click the one instance that you should have running. Go under instance, or excuse me, oops, sorry, go back. Apologies there. Go under actions, go under security, modify IAM role, and then just click the Pulumi Workshop Admin and hit save. And then we should be good to go. And then the next thing we need to do is go back to your Cloud9 environment. Go ahead and click this little gear icon here. Bring this down so people can see. Go to AWS settings, turn off the AWS managed temporary credentials, and then you can just go ahead and click X here. And then the last step is we just need to install some of the tools that we'll be using for today's workshop. And so we've actually included this in the content, so you can actually just copy and paste this right here. And just copy paste. And that'll just take a few seconds to run. And so while this is running, just a quick temperature check. Does anyone need help? Do we need more time? Let us know if we're moving too quickly.
I just sent a poll out, so if you just could, once you're done setting up your Cloud9 environment, just hit yes in the poll, and we should be able to get an idea of how many people are ready to continue.
And then once that's done running, just hit enter one more time. And then if you followed all the steps correctly, it should output IAM role valid. And so once you see that, then you have completed setting up your environment for today's workshop. And so with that said, I'll hand it over back to Lee.
Thank you so much. I'm going to wait a few minutes because we've got a few of these poll results coming in, and it's about a 50-50 split. So I want to make sure everybody is ready and up and running. If you need a few more minutes, or if you need any help or assistance, please reach out to us in the public chat, and we can reach out to you directly to make sure that you're all ready to go. But while we're waiting for that, I'm just going to talk a little bit about what we're going to do today. So this is a 3-part workshop. Part 1 is going to see us set up an Amazon EKS cluster using Pulumi's Crosswalk library, which will show you how easy and straightforward it can be to kind of launch an EKS cluster in Amazon with Pulumi. The second stage, we will be installing a key component of any Kubernetes cluster into that EKS cluster called an ingress controller, and we'll be doing the Amazon load balancer. Amazon load balancer controller will be installed, and we'll be doing that in Python. So the first step will be in TypeScript, the second step will be in Python, and then finally we will be creating a very special mechanism to kind of deploy something to that Kubernetes cluster. But I'll leave that to the end. But we'll be using a third language there, Go. So we've been very, very ambitious with this workshop. We're going to cover lots and lots of content. We're going to cover lots and lots of Pulumi's features. So I hope everyone's excited. I'm going to take a look at the poll. It looks like we're kind of getting into a better place there. So I'm going to wait 30 more seconds. If there's anybody who needs any help, then please feel free to let us know. Okay, I have set up my IDE in the same way that Andrew guided us through. In order to kind of do the next step in the process, we actually need to install Pulumi in the Cloud9 environment. I can no longer see the comments coming from the chat. So if you do have a question, please let me know in the public chat, and my wonderful colleague Zach will interrupt me and tell me and read back the question to me. So there is somebody still kind of monitoring the chat who will interrupt me and kind of ask any questions. I do encourage you to ask the questions that you kind of want to know the answers to while I'm in the process. I'm quite happy to answer the questions. But let's get moving with Pulumi. So we're looking at still at the prerequisites page here, and we're on install Pulumi and Pulumi language dependencies. So there's a couple things that we need to install here, and I'm going to copy and paste this because that way I don't have to type it all out. But we're going to use Pulumi's installer script to install Pulumi into the Cloud9 environment. So I'm going to hit enter, and you'll see it's going to download the latest version of Pulumi. It does not need any elevated credentials to install. It installs everything in the .pulumi directory in our home directory here. But in order to make sure that we can actually use it, we need to set up our bash environment. So there is a command that says source.bashrc. We'll hit enter here. What we should now be able to do is do Pulumi version. And you should get this version returned, version 2.15.4. And that means that Pulumi now is installed and ready to go on our environment. The next thing that we need to do is we need to log in to Pulumi so that we can store our state somewhere. And Pulumi has a command that takes care of this for us. So we're going to do Pulumi login. I'm going to hit enter, and you'll see that it will prompt you for a token. If you're doing this on your local machine, it takes care of all this for you. But because we're doing this in a remote environment, we need to paste a token in here. So I'm going to open this link, and you should see it will take me to app.pulumi.com to the access tokens page. And I already had a Cloud9 token there. So I'm going to hit new access token. I'm going to give it a description of Cloud9. And you'll see it will create me a nice long token that I can then copy into my environment. So hit the copy access token button. And I'm going to then paste it into here. Now, it's important to note, I've pasted it in here. It hasn't shown me any user feedback. So we don't echo the token to the screen. So make sure after that you hit enter. And you should know that you have logged in successfully when you get this lovely welcome to Pulumi introduction. And you'll see that it's going to give you a tip of the day. This now means that you have been logged in. And you should see as well, like you should see a note at the bottom here that says you're logged into Pulumi.com as my username, which is JackStorm in this particular case. But just remember, when you paste in the token in here, it doesn't give you any feedback. So don't paste it twice. And if you do paste it twice, type Pulumi login again and have another go. The final piece of setup that we need to do is we need to install the kubectl command into our environment. Now, lots of people pronounce this in different ways. I pronounce it kubectl. Some people call it kubectl. Some people call it any other kind of way that you want. But we're just going to copy and paste the setup instructions here. So if we scroll down on this install Pulumi and language dependencies page, just copy this here, and it will download the actual kubectl binary locally. And you can see it's now available here, this kubectl command. And I'm going to make it executable using the chmod command, like so. And if I type ls, you'll see it's now turned green. This is a good sign. And then I'm going to move it into a place where I don't need to, into my local path. So I'm going to do sudo move kubectl user local bin. And you can verify that everything is set up by doing kubectl version -- client, like so. And if you get this kind of thing returned to you, so you should see version v1.20.0. If you have done that, you are ready to use Pulumi. So I'm going to take a quick pause there, make sure everybody's good to go. If you are stuck or you need a little bit of time, please let us know in the public chat, and we can just take a pause there. Okay. So again, if you need more time, please let us know in the public chat, and my colleague Zach will interrupt me. But then now that we've
Hey Lee, I'm actually gonna interrupt you. Can we wait about 30 more seconds? I think we have one person still getting caught up.
Certainly can.
Okay, Lee, we should be all good to go.
Excellent. Thank you very much. So we have this amazing AWS workshop page, and you'll see there's actually multiple different workshops that we've done over the last few weeks here. In this particular case, we're going to choose this building a Kubernetes platform in Amazon EKS. It's at the bottom of this list on the left-hand side. If you want to just click on that, and you'll see we get our introduction page. And there's 3 modules that we're going to cover today, and obviously we're going to start at module 1. I'm not going to always show this page, and so if you are stuck on where we are in the content, then please let me know, or please let us know in the public chat, and I can kind of show you. But from this point on, we're going to be following this pretty linearly, and so like you should be able to kind of copy and paste a lot of the stuff that is in here if you want. I will be typing a lot of this, time dependent, but let's get started. So I'm going to start here on creating a new project, and we're going to set up our very, very first Pulumi project. Okay, so as it tells me, I need to first create a directory. So I'm going to create a directory called workshop cluster, and I'm going to move into that directory, and then I'm going to bootstrap my Pulumi project. And the way that we do that is we use the Pulumi new command. So I'm going to type Pulumi new TypeScript, because this particular Pulumi project is going to be done in TypeScript. And it will prompt me for some values. So it asks me for a project name, which is usually the name of the directory that you're in. So I'm going to take the default there. I'm going to use the default project description. And then it's also going to prompt me for a stack. Now, if you aren't really familiar with what a stack is, we do an introduction to Pulumi workshop where I talk about this in a lot more detail. But a stack, you need at least 1 stack in every Pulumi project. And a stack is configurable. So it's going to let me add configuration options on a per stack basis. So if I hit enter now, you'll see that Pulumi takes care of adding all of our dependencies to this Pulumi project. So it's installed a bunch of npm packages because we're using TypeScript, and it's told me that my project is ready to go. On the left-hand side here, you'll see this is now my workshop cluster project, and there's a bunch of files in this directory. There is a pulumi.yaml, which is basically populated with a lot of the things that we just put in our wizard that came up. So workshop cluster and the description. And then you can see there's other things that are pretty familiar to you if you've ever programmed in a JavaScript language. So we have an index.ts file, we have a ts config for our TypeScript config, and a package.json, which manages our dependencies. So our Pulumi project is kind of set up now and ready to go. And if I look in here, you'll see we have the Pulumi SDK default dependency added. That's a very, very basic project. That's the most simple project that you can kind of put together. But in order to interact with AWS, we also need to add what we call a provider. And there's lots and lots of different providers available. We're going to use the AWS one today for obvious reasons. We're operating in AWS. And if you are familiar with JavaScript, this is going to look pretty familiar to you when you add this provider. So I'm going to use the npm command to install these dependencies into my project. So I'm going to do npm install at Pulumi AWS. And it's very similar to what we saw before. It's installing an npm package, and then it's also installing what we call a resource plugin, which is what Pulumi needs to interact with AWS. So I've now got 2 dependencies in my project, but I need a third one. And the reason for that is we're going to actually use one of Pulumi's, one of my favorite Pulumi features, which is AWS Crosswalk for Pulumi. And that is a piece of functionality which allows you to be much more productive when you're interacting with AWS. So some of the smart people at Pulumi have got together and created a bunch of TypeScript libraries that will allow you to define your infrastructure in a best practice way with the less code. And so let's install that now. I'm going to do npm install at Pulumi AWS X. So don't forget to add the X at the end there. That's super important. So that's what we call our crosswalk package. So let's do an npm install now. That's installed all ready to go for us. And then what we need to do next is we actually need to tell Pulumi which AWS region we're in. And so we're going to use the Pulumi config command to do that. So Pulumi config set AWS region is US West 2. You'll see on the left here what's happened is that this dev file has appeared. And what that is it's telling Pulumi that we have a stack called dev, and we have some configuration for that stack, which is the AWS region. The reason we're doing this explicitly is that it's a very common pattern in Pulumi to have different regions for different stacks. And these stacks are super configurable. So, you can then basically use the same code to deploy to multiple AWS regions using a stack for each region, or maybe even different AWS accounts using a stack for each account. So make sure you remember to kind of run this command as part of the process, and that kind of finishes the first step in setting up our Pulumi project. So we should have a Pulumi configuration set, and we should also have installed a couple of dependencies. Now we can actually import those dependencies into our Pulumi program. And again, this is just a normal TypeScript program. So if you've written anything in TypeScript or JavaScript, this will look very familiar to you. So I don't want to destroy that. So import all as AWS from at Pulumi AWS. And then I'm also going to import my AWS X library. Can't type today. And I missed an as there. So I've imported these 2 dependencies that I've added to my project, and they're now ready to use, which is what we're going to do in our next stage, where we're going to create an actual cluster. An actual cluster in a VPC. So I'm going to pause there. Don't forget to hit file and then save as to file save all to make sure everybody is kind of up to speed. And I'm going to take a quick pause there, and then we'll get started kind of creating our cluster. And if you are wondering at this point, I do understand we've dived right into this and we're writing code already. I am going to kind of loop back on this once we're kind of finished with this first section and kind of explain some of the concepts that we're talking about. I just want to kind of get us up and running as quickly as possible so that we can start to get to the really good stuff. Okay, so let's define, the first thing we need to do for an EKS cluster is we need to actually have an Amazon AWS VPC for it to run in. And Crosswalk can really, really help here, because usually when you're setting up a VPC, you have to design dozens and dozens of resources in order to actually make that effective. But with Crosswalk, we can do this in about 30 lines of code. So the first thing I'm going to do is define a variable called name that we can pass through to a bunch of the other resources. I'm going to call mine L. Briggs Workshop. I would recommend changing this unless you want to call your VPC and stuff, you know, by my name. And then I'm also going to define another constant called cluster name. And I'm going to use the TypeScript and string literals to actually kind of use this. So I'm going to use the name that we have here for my cluster name. So I'm basically I'm going to pass this to a Pulumi resource in a few minutes. The final constant I want to set up is a cluster tag constant. And this is really important. And I'll talk a little bit about why in a few minutes. But what I want to make sure is that this tag exists on certain resources so that EKS will know which of the resources in the account to actually use. So make sure that this is added. It's super, super important. Here's my 3 variables. Now I need to pass them to something. So I'm going to use AWS Crosswalk to define a VPC. And the way that we do that is we define a constant, and then we use the AWSX library to kind of set this up. And each resource in Pulumi needs to have a name. So we're going to use our name that we defined earlier, this constant, inside our resource. And then we need to pass some parameters. I just missed this new here, so make sure you don't forget that. And then for an AWS VPC, we need to define an IP address range that it will use. So in this particular case, I'm going to use this. You can kind of use any private range here if you want, but I recommend if you're following along at home to stick with what we currently have in the tutorial. And then I'm going to define 2 different subnets. One for private access, so that's not routable from outside of the AWS VPC, and then also a public one. And so again, AWS Crosswalk is doing a lot of the work for me here. If I was want to do this manually, it would take, I'm already at a VPC, an internet gateway. I have to figure out which subnets go on which tier. Like all of this, if you kind of do this even in CloudFormation, this is hundreds and hundreds of lines of YAML, but you can do this with Crosswalk very, very easily. So let's set the type of subnet that we want here, private. And then also put the tags on some of these subnets that we need. And so I'm just going to copy and paste this real quick so that I'm not wasting everybody's time. So here you'll see that I'm using this cluster tag, and I'm specifying a tag on the subnet itself. That's really, really important for EKS to operate properly. And then I'm also going to do basically the same thing, but with a public subnet. So let's copy and paste this just to make sure that we're kind of being efficient with our time. So you'll see I've copied and pasted my public subnet definition as well. I'm using the cluster tag again to make sure that EKS will know that the subnets we're about to create are owned by EKS. By this particular cluster. And then I'm also going to add a name to the VPC here. And so I can do that right down here. Name equals name VPC. So in less than 30 lines of code, we've defined best practice two-tiered Amazon VPC. If you've done this manually at any stage in your career, you'll know that this is a really, really difficult thing to do in a best practice way. But using the power of Pulumi's crosswalk library, we've done this very, very quickly. And I realize I am running through this very, very quickly. And there's a reason for that, and we'll see that in a few minutes. So I'm not going to pause here. I'm going to very quickly kind of move on into the next step, and then we'll take a pause after that so that we can kind of take a breath and make sure that we're all kind of where we need to be. So I've defined a VPC. The next thing that I need to do as part of this Pulumi project is set up an Amazon EKS cluster. And so I need an additional dependency for this to actually set this up. So we have the Amazon AWS crosswalk library, which deals with a lot of the infrastructure in AWS in a best practice manner. We also have Amazon EKS for Amazon crosswalk for EKS, which allows us to set up a best practice Kubernetes cluster. So I'm going to come back to my terminal and do npm install @Pulumi EKS. This is in the workshop content. If you are stuck at any point, you can just kind of copy along from there. And so I'm going to hit install. And you'll see it's installed. It's installed a bunch of dependencies for me again. But now I'm ready to kind of define a cluster. And so as always with any kind of TypeScript library, we need to import it. And then we actually need to define the cluster. And so we're going to, I'm going to copy and paste this to make sure that we are, being good with our time. And then once I've kind of run this in a few minutes, I'll talk a little bit about what's going on here. So I would encourage you to take a look at step 2 in the workshop content. And if you are feeling like this is all going a little bit too fast and you're not really sure what's happening, copy and paste this code here and paste it into your project, and we will run this now, and then I'm going to talk a little bit about what's going on here. So make sure you don't forget to hit File, Save All, to make sure that all the stuff that we just put in here is kind of done and ready to go. And now in my terminal, I'm going to run Pulumi up. And now is where we're going to actually see the fruits of our labor here and see where all the magic has happened. So what this is going to do is it's going to create a bunch of different resources, and you can see this long list here. And because this is going to take us approximately 15 minutes while this runs in the background, just go ahead and hit yes, and we'll kind of let that do its thing in the background. So the reason that I've rushed through this particular part of the content is because this is going to take a little while for it to run in the background. And the reason for that is there's several resources which we're provisioning here, which do take a few minutes for Amazon to actually provision. So I'm going to pause there. If you got stuck at any point, take a look in the content under the create an EKS cluster thing here and copy and paste the code. In step 2, you'll see it says the index.ts file should now have the following contents. Copy and paste this code into your IDE, into your Cloud9 IDE, and then go back to your terminal and hit Pulumi up, and it should provision a cluster for you. And I will now take a breath. If there are any questions, now is the time to do that. And while that's running in the background, I'm going to do a little bit of an explanation about what we're doing here and what we just spent doing the last kind of 10 to 15 minutes doing. Okay, so let's go back to our code while this is running in the background and talk a little bit about what we did here. So I mentioned that we have Pulumi Crosswalk for Amazon Web Services. And the reason that we've kind of put together Pulumi Crosswalk for Amazon Web Services is because we realized that often there are a lot of people kind of doing the same things in AWS. A lot of people want to define a VPC. A lot of people want to define an RDS cluster. And often they were asking questions like, what's the best way to do this? What does a best practice VPC look like? We were getting regular questions. And so Crosswalk is an attempt to kind of abstract a lot away from you, the user, so that you can just be more productive when you're defining these resources. And so what this AWS Crosswalk usage here of kind of doing a VPC is doing is it's actually taking care of a lot of different resources for you that we know that you will need when you are defining a VPC. So you can see here in this dependency graph, as Pulumi is running in the background, you can see that we have the actual AWSX resource here. And then there's a lot of different things underneath this that you as a user have not had to provision. So you haven't actually had to write a VPC or a bunch of subnets with AWS route tables, for example, here. All this stuff is kind of taken care of for you by Pulumi. And I think that is a good time to kind of go back to the slides and talk about a little bit about what Pulumi is. And so I'm going to bring this up real quick, and I'm going to hit slides. And we're going to talk a little bit about what Pulumi is, as I talked about before. So Pulumi, if you're not familiar with it, is a modern infrastructure as code platform that allows you to use the familiar programming languages that you use in your application lifecycle, such as TypeScript, as we just saw there, and you can use those to actually provision code infrastructure in a kind of familiar way. And we kind of look at ourselves as a product for the entire cloud engineering organization. And what we mean by that is that often it's the case that there are people within your organization who want to provision cloud infrastructure, but they don't want to have to learn kind of a DSL or a big long configuration language in order to actually be productive in their kind of cloud journey. And that allows you to kind of really do some of the things that we've already seen. So you'll already notice that we've been able to install AWS Crosswalk as an npm package into our actual environment, and it's using all of the same tools that if you're a front-end developer using TypeScript or a kind of back-end developer using Go, you can use these same mechanisms to kind of provision infrastructure. And we have two parts of what we call the Pulumi platform. So there is the Pulumi SDK, which is what we're using right now when we're kind of provisioning our Amazon VPC and our AWS EKS cluster. And the Pulumi SDK includes the Pulumi CLI, and it includes all of the different packages that we've installed. So all the different providers, like our Amazon Web Services provider, is all open source and available on GitHub. You can use them straight as they are off the shelf. And then we also have something that you've already signed up for as well, the Pulumi console, which is a mechanism for Pulumi to actually store what it's done when it interacts with those cloud providers. So Pulumi needs a way to store its state, somewhere to actually kind of write, oh, I just created all these resources, and Pulumi needs to know what those resources are to keep track of them. And so we use a state to do that. The Pulumi console is free for individuals. And we also have an open source offering where you can store that state in a Amazon Web Services bucket or a Google Cloud bucket or an Azure bucket. Any kind of object store is available to use as well. We also have some amazing features, which I'm going to talk about hopefully at the end, around being able to kind of collaborate with your team and kind of share different things and provide policy and all that kind of stuff. So, as I've already mentioned, Pulumi, we believe in using familiar programming languages to define your infrastructure, and we kind of cover 4 ecosystems right now. We have the Node.js ecosystem, which we're currently using to define our VPC and our Kubernetes cluster. And then we also support the Python ecosystem, which we'll be using next. And we support the Go and the .NET ecosystems. And the reason that I'm talking about these different languages is because one of the things that's really important to know is that you are not pinned into a single language when you start using using Pulumi. You can use different languages between different projects. And we're going to see an example of that in a few moments. But it's really important to know that if you're kind of an organization that has multiple different programming languages available, like if your front-end engineers are using TypeScript and your back-end engineers are using Go or Python, they can both use Pulumi in the languages that they feel comfortable with, which is really, really empowering if you're a developer. You no longer need to learn this kind of new tool or this new language in order to kind of get going. What's great about using these, these different programming languages is that you can then also use all of the tooling that you use in your software development lifecycle when you're provisioning infrastructure as well. So as you've already seen, we're using AWS Cloud9 today. I'm a huge JetBrains user. I love the JetBrains suite of products. So I usually would be using that if I wasn't having people follow along. I know we have a lot of people using VS Code that are kind of using these editors to kind of get the most out of provisioning infrastructure. That also means as well that you can do things like write unit tests for your infrastructure. You can make sure it's linted correctly. And then you can install things, as we've already seen, using the package managers that you're familiar with while you're actually kind of developing applications. So you can develop your own kind of like version of AWS Crosswalk internally for your organization, and you can distribute it using NPM or Python, which is really, really empowering, especially if you kind of want to share share a bunch of stuff with people within your organization. So that's my little introductory spiel. I'm going to go back to my screen now, and we'll see how our provisioning is going. So you can see we have created an Amazon VPC here. It's created a bunch of infrastructure like a VPC and NAT gateway and all that kind of stuff. And what's happening right now is that an Amazon EKS cluster is being provisioned in the background. And again, that does take a few minutes. So while we wait for that to happen, I'm going to take a pause. I'm going to very, very quickly send out a poll. We already talked about which of the languages that you might have used, but I also want everybody to kind of let us know, have you used Pulumi before? So there should be a poll ready for you right now. I'd love to hear if you are kind of coming to Pulumi today completely brand new, or if you've maybe used Pulumi a little bit in the past. So while you're waiting, just feel free to kind of hit yes or no on the poll. It's great feedback for us to have. Hey, I just saw there's a couple people that are joining a little bit late. If you are joining a little bit late, you can just either watch along, kind of watch me kind of do the provisioning, or if you really, really would like to join in and you don't mind kind of being a little bit behind, just start at the prerequisites here on the left-hand side of the Pulumi AWS Workshop website, which is in the handouts, and kind of follow along to the prerequisites. And then finally, we're on the building a Kubernetes platform in Amazon EKS. So we've just completed module 1, and we're currently waiting for our EKS cluster to be provisioned. So if you do want to follow along, if you've just joined, then that's totally okay. If not, then you do just feel free to kind of watch as we kind of learn things together. Really appreciate everybody's responses on the poll. There's a second poll coming in now where I'm going to ask which of the Pulumi language ecosystems that we've talked about you might use as you kind of go through your Pulumi journey. So there's another poll there. There's 4 options. You can choose multiple options. So please feel free to choose 2 or 3, or if you are really, really brave, you might use all of the different language ecosystems. So go ahead and just kind of let us know which of those things that you might be using. We're still waiting for our Amazon EKS cluster to be provisioned. Again, this does take a few minutes, so this is not a great surprise. So while we're waiting for that, if there's any questions or anybody would like to kind of like follow any Pulumi fundamentals, then please feel free to let us know in this chat, and I'm quite happy to take some questions. Does look like we have a lot of Python users here today, which is always good to see.
Hey Lee, as we wait, might be a good idea to show off the organizations feature of the Pulumi console to everyone.
That's a great idea. So while we're waiting for this, as Zach just said, one of the things that I did want to make sure everybody was familiar with is that what does an organization look like in Pulumi? And so when you signed up, you probably only have one organization, which is probably your GitHub username. This is my organization here. And so I have a bunch of stacks and a bunch of projects that I've created in the past. And every single user who signs up to Pulumi gets a free individual account that they can use to provision different infrastructure. And you can see I've got lots and lots of different projects going on here that I've kind of used in the past. But then there's also a organizations feature. And this is part of our Team Starter and Team Pro and Enterprise plans, which allows you to collaborate on these different things with your peers. And so you can see I'm a member of the Pulumi organization. If you take a look at the people, you can see all my wonderful colleagues that are a member of, of my organization. And then there's also a Teams feature. So you can kind of group all of the different people within your within your organization. So we have an engineering team, and then we have people who work on www.pulumi.com. One of my favorite features about this is that we have also these policies as well, which means that you can actually enforce infrastructure as code policies within your Pulumi organization. So that basically, a great example of this is if you don't want actually people to create certain resources, or you don't want people to be able to, you want to make sure that everybody has tags on their resources when they kind of provision stuff, you can kind of define these within the Pulumi SaaS, and it will mean that you can enforce them so that you can stop people creating resources that they shouldn't be allowed to do or anything like that. And this is really great for compliance. It's really great for a lot of different kind of cases and situations. So if you do want to try out the new organization, the organizations feature, if you do hit the new organization, you can sign up for something like that and you will get a free trial for 1 month. 2 weeks. Can't even figure that out. So, it's probably a good idea to sign up for whatever your organization is called. So if I call mine LBR Labs, for example, and then you can just hit and then start free trial, and you get a 2-week trial, no credit card needed. So you should be able to get set up nice and easy, and then add a bunch of people to your organization. So I would recommend kind of having a look at that if you plan on using Pulumi collaboratively as part of your workflow. Still creating our cluster. This is taking a little while. So what I'm going to do here is just kind of do I'm going to start the second module in parallel while waiting for this cluster to provision. So this could take a couple more minutes, and I don't want to be sat here while everybody waits. So what I'm going to do now is, while waiting for that to finish, I'm going to move on to module 2. And we're going to talk a little bit more about how different parts of Pulumi work while we're waiting. But if you are following along at home, hit module 2 here, and we will start on that any minute now. So in order to kind of get moving a little bit here, I'm going to hit the plus button in the top of the Cloud9 IDE, and we can open a new terminal, which means we can kind of do this stuff in parallel, and we can switch backwards and forwards while we do stuff. And I know that's going to be a little bit difficult to kind of follow along, but I do want to make sure that we are kind of using this time effectively instead of kind of sat waiting for the EKS EKS cluster to kind of get going. So let's create our second project. Our second project is going to be the AWS load balancer controller. And if you are familiar with Kubernetes, then you'll know that something like a load balancer controller is really, really important in order to actually kind of use Kubernetes in an effective kind of platformified way. So when you spin up a Kubernetes cluster, there's a few things that you sometimes need to layer on top of Kubernetes to make it usable for people within your organization. So let's create a new directory called make directory AWS load balancer controller. And I'm going to move into that. And then I am going to provision a new AWS Python project. Before, what we did is this, and we had to populate our AWS Python program manually. But we do have a bunch of templates that are available for you to use that are like language specific, but also for different clouds. So I'm going to do Pulumi new, and you get this really fancy drop-down box here. And then I'm going to select AWS Python. and it will prompt me for a project name like all of the new Pulumi projects do. So I'll hit enter. I'll use the default project description. And then I'm also going to use the default stack name, in which case is dev. And then it'll ask me for my AWS region, which we know is US West 2. So I'm going to type in US West 2. What this is going to do is it's going to bootstrap my Pulumi Python project now. And you're probably wondering, well, hold on a second. We wrote a bunch of code in earlier in TypeScript. And now we're using Python. And the reason that I'm doing this as part of this workshop is because one of the things that I think is important as part of a kind of Kubernetes environment is really making sure that you're meeting the people who are consuming your Kubernetes platform where they are. So you're meeting them in a mechanism that like they're using the tools and the languages that they feel comfortable with. And, you know, if I'd have done this whole workshop in one language, you may have left feeling like, okay, I need to do all of this stuff in TypeScript, or I need to do all this stuff in Python. And that's just not the case. You can kind of install multiple different things into your AWS environment or your Kubernetes environment using whichever language that you feel comfortable and familiar with. I'm just going to quickly check. This is a good sign. It says my cluster is ready. So it's just going to wait a few more minutes to make sure it's actually ready. So we'll just kind of wait a few seconds there. And while we're waiting for that, we're going to install the dependencies, a couple of extra dependencies into our AWS load balancer controller Pulumi project. So let me get rid of all of this. And you'll see that this is a Python project, so it looks a little bit different to our workshop cluster project. And you'll see that it has a Python virtual env, it has a main.py file, and it has a requirements.txt. The requirements.txt is Python's mechanism of kind of managing the dependencies. And let's take a look at the requirements.txt. You'll see that we have the Pulumi Python pip package and the Pulumi AWS Python pip package. And so we can use those now to be able to kind of interact with Python. If we open up our main.py, and you'll see in the top left here, we can open this up. You'll see what it's done is it's filled up our Pulumi program with some boilerplate code to let you know that like this is an example of a Pulumi Python program. And we're not going to use any of this. So I'm going to just drag over all of this, and I'm just going to get rid of all of it. I'm going to delete it all, and I'm going to leave a single thing here, import Pulumi, to make sure that we're actually using the Pulumi program, sorry, the Pulumi SDK as part of our workflow. So we've got rid of a bunch of stuff there, and then we need to install, because we're going to be interacting with both Amazon Web Services and Kubernetes during this part of the workshop. What we need to do now is install the Pulumi Kubernetes provider. And Python has its own mechanism of managing dependencies, and it uses something called a virtual env to do that, which Pulumi set up for us, which is here. But to make sure that we're actually installing our dependencies inside that virtual env, I am going to activate it. So I'm going to do source bin activate, and you'll see if you've done something successful there, you'll the Cloud9 IDE very helpfully tells us that we're in that virtual env now. And then I'm going to do pip3 install Pulumi Kubernetes. And you'll see there's a bunch of the dependencies have already been pulled in by other kind of dependencies like the Pulumi AWS, but it has downloaded the Pulumi Kubernetes provider for us, and that's all been successfully installed. So we're now ready to use Python for one of our projects as well. While I'm waiting for that, I am going to just double check. Excellent. We have a working Kubernetes cluster, 19 minutes and 5 seconds. So that took a little while we were waiting for that. I do realize we're doing a little bit of context switching here. So if you're kind of like struggling to follow along, then please let us know. And I'm quite happy to either slow down or do some more explanation of what's happening. But just to kind of confuse things a little bit more, we're now going to switch back to our original Pulumi project. So we're going to go back to workshop cluster, and we're going to add something to our TypeScript file so that we can utilize them in other projects. And I'm going to take a second here to do a little bit of an explanation. So when you create a Pulumi project, you create these resources and you assign them to variables. So we've created two kind of variables here, a VPC variable and a cluster variable. these variables kind of contain information about what was created on the Pulumi side, and we call those outputs. A Pulumi output is something that gets returned by an API or a provider that the Pulumi doesn't know until it's been returned from AWS or from Kubernetes. And you can see lots and lots of examples of these if you just do cluster dot, and you'll see that there is a bunch of different things that are going to be created from these resources. And what's great about Pulumi is that you can pass these resources between different pass these outputs between different resources. And if you look here, that's what we've done when we're creating our Kubernetes cluster. We've defined a VPC, and then the cluster needs to know which private subnets and public subnets it is going to use when it's creating the cluster. So we passed the VPC outputs, which is in this case a private subnet and a public subnet. We've passed them from the VPC resource to the cluster resource, and this creates dependencies between two different resources. So what Pulumi now knows is that because we've passed these outputs from the VPC to the cluster, Pulumi knows create the VPC first and then create the cluster. Do it in that order. And that's really, really useful to creating dependency graphs. But just to make things even more awesome, you can actually pass these values, these output values, not just between resources, you can pass them between different Pulumi projects as well. So if we go back to our, I'm going to drag this over. If we go back to our create an EKS cluster section here of our workshop content, you'll see right at the bottom, what we do is we kind of export. We use the export command, so the export function here to export these values outside of the project as well. So later down the line, when we're defining our different things that we're running in our Kubernetes cluster, there's some of the values that have been created by our cluster need to be passed to other projects. So I'm going to copy and paste this particular section here. So you see the export const thing, and I'm going to copy this into my Pulumi program. And so what this is going to export is the name of the cluster that we've created, the VPC ID, which is going to be important later on, and then there's a bunch of other different parameters from the cluster that we need. And then finally, and one of the most important things is we're going to need to export the kubeconfig, which is the thing that allows us to actually access the cluster itself. So I've added 5 lines here. These are really, really important. So make sure you do it with the correct name as well. I'm going to hit File and Save All. And then I'm going to run Pulumi up again on my workshop cluster project. And you'll see that the Pulumi output has now changed, right? So what's happening now is that none of the actual resources have changed because we haven't changed anything in the cluster. We haven't modified any values at all. So Pulumi knows it's looked at the state that's stored in app.pulumi.com, and it's looked at the running resources and said, I don't need to change anything here. But the person has now exported a bunch of values as outputs. So it's showing me what it's going to output here. It's going to output the cluster name and the OIDC provider things. And then it's also going to export the kubeconfig as well. So let me hit yes. And it's telling me that 59 resources are unchanged, but we are exporting outputs. And now that means that I can now reference these in 2 different ways. The first way that I can reference them is I can run Pulumi stack output, and it will show me a list of outputs. But then I can also specify a specific output, and I can use it in different mechanisms from my shell as well. So what I'm going to do here is I'm going to pipe this kubeconfig. I'm going to pipe it into this file here, .kubeconfig, which is where the kubectl command that we used earlier, that is where it looks to be able to interact with our Kubernetes cluster. So I can write this output that I've created from my Pulumi project. I can write it to a file, right? And so it showed me that it's written to a file, and I should be able to look and see that if I look at .kubeconfig, You'll see there's a file there now. And then moment of truth, I should be able to run kubectl get nodes. And you can see it's now letting us access directly from our Pulumi, from our kubectl command. We can now actually see that a Kubernetes cluster is up and running, and it's got the 2 nodes that we've specified here. You see the desired capacity of 2. So we've now got new node, like a Kubernetes cluster is up and running, and it's ready for us to interact with our second Pulumi program. Okay, going to take a pause there. Make sure that we kind of, everybody who's following along is able to kind of keep up. But we are now done. We're finished with our first Pulumi project, the one that takes 20 minutes. And we're done with TypeScript for this part of the workshop. So there's going to be no more TypeScript. So we've only used it to define one part of our kind of infrastructure.
Hey, Lee, we have a question in the chat.
Sure.
The question is there any mechanism where Pulumi creates a stack using available languages using existing CloudFormation Terraform template?
There is 2 mechanisms for that. So first of all, there is a Pulumi resource called CloudFormation. Let me bring that up real quick. Pulumi CloudFormation. Here we are. So you can actually reference you can actually create a CloudFormation stack using Pulumi, or you can get an existing CloudFormation stack using Pulumi. So Pulumi has these get functions that allow you to reference existing CloudFormation stacks that you want. You can't transpile a CloudFormation stack into Pulumi yet, and I'm going to use that very tentatively because this is something that is on our hopeful roadmap where we'll be able to convert CloudFormation to Pulumi. But you can't do that just yet. You can reference existing CloudFormation that you've created. However, if you are a Terraform user, we have the wonderful TF2 Pulumi, and this comes in the form of a binary or as a web page, and you can see if you do, Zach, if you wouldn't mind just posting this link in the chat, in the handouts, you can actually take existing Terraform, paste it into this website, and it will convert it to Pulumi code in whichever language you like. So you can change it to Python or Go or C#. I personally love this because I was very familiar with Terraform once upon a time, and it allowed me to not only become a better software developer because I was taking something that I already knew and then I was able to convert it to different languages, but it also meant that I could be way more productive. So if you are interested in kind of making the switch, then we do have these awesome tools that are available to kind of do the conversion. So in summary, you cannot yet currently convert a CloudFormation template to a Pulumi program, but you can define a CloudFormation stack using Pulumi. And if you want to convert from one to the other when it comes to Terraform, use TF2 Pulumi. Hopefully that answers the question. Okay, so let's kind of move on with our AWS load balancer control. Let's get that created. So we set up a second Pulumi program. I'm going to close all this down because I'm not going to need it again for a little while. So let's close that. And so now we're dealing mainly with the AWS load balancer controller here. And so we have this Python project with a virtual env, and we've installed a bunch of dependencies. And we want to make sure that we're kind of importing these dependencies into our Pulumi program. So I'm going to do import. And of course, we switched to Python now, so the syntax is a little bit different. But I'm going to import Pulumi Kubernetes as KS. So I'm just going to give the Python program like a short name so I don't have to type out Pulumi Kubernetes each time. And then I'm going to do the same thing with the AWS provider as well. So we've imported our 2 packages now, and we're ready to use them in a similar way that we did with our TypeScript program. I'm just going to very quickly make sure that I'm going to get my autocomplete working. So I'm going to open terminal here, working directory. Ooh. Copy this. What I'm doing here is that because we've installed these dependencies in a virtual environment, I want to make sure that my autocomplete works in my IDE. So what I did is in my AWS load balancer controller, I expanded the VM folder, and then I expanded the lib64 folder, and then the Python 3.7, and then I opened the terminal in that location, because this is where all my packages are installed, right? So you can see Pulumi AWS, Pulumi Kubernetes is all installed in this virtual env. And then I grabbed the working directory, like this, copied it, and I went into my settings, into Python support, and then I just added it to the end here. And like you don't necessarily need to do this if you just kind of copy and paste in the code from the workshop. But if you are following along and you do want to get the autocomplete, I would recommend just quickly doing that because it makes your life a little bit easier. Don't need that terminal anymore. And I don't need that terminal anymore. Okay. So we've imported our dependencies. It's now time to actually get started writing some Pulumi code to provision things to Kubernetes. And I am going to start, though, by making sure that we are getting values from our workshop cluster project. So we need to know those values that we exported, like the cluster name and the kube config and all that kind of stuff. We need to pass them into resources inside this Pulumi program. So what I'm going to do is I'm going to set up something called a stack reference. So I'll create a variable called stack, and I'm going to call it, I'm going to run the get stack function here, so that we can grab the actual current stack that we're in, which at the moment is dev. And then I'm going to do cluster equals Pulumi dot stack reference. And I'm going to use a Python f string. And I'm going to say my Pulumi org. So this will be, if you are following along at home, do not type jackstorm because you will not have access to that stack. Use whatever your GitHub name is or your Pulumi name is. And then I'm going to reference the actual name of the project. So in this particular case, it's workshop cluster, which if you remember is the name that we gave our initial workshop project. And then I'm also going to say that I want to use whatever stack we are currently in. So we have two projects. We have this one, which is the workshop, the AWS load balancer controller. And we also have the workshop cluster. They both have a dev stack. And so I know that I can use this stack value here as part of my stack reference. So what this is doing is it's saying, grab the values from the workshop cluster, from that first project that we created, and reference them when we want to later. So it's grabbing all of those values from that. And then next of all, we need to grab a couple of outputs. And so what we do here is we use this stack reference to grab those outputs. So I'm going to do new variable, cluster dot get output, like that. And then the name of the output that I actually want to grab. So I know I'm going to need these later, so I'm just going to do OIDC URL equals cluster dot get output cluster OIDC provider. And you're wondering, like, if you're wondering where these values are coming from, like, well, how did I know what those are? Well, they're coming from our initial workshop cluster project. So it's this value and this value that we're currently retrieving from our original stack. And this is what the mechanism is that allows you to kind of make these things developer friendly. So you kind of I think of these as like an API. If you're an infrastructure team or you're defining infrastructure, you can say, these are all the things that you are going to need to know to interact with our infrastructure. And you can just reference them as a stack reference and an output. So you can just say, I've created a Kubernetes cluster for you. I'm an infrastructure person. And if you're a software developer person, and you just want to deploy to that Kubernetes cluster, you can just grab them directly as code. You don't actually need to figure them out and all that kind of stuff. You just say, hey, what are the outputs that I need? And you could just grab them from there. Okay, so we're going to run a workload in Kubernetes, but that workload in Kubernetes is going to need access to IAM credentials in AWS to actually operate and work correctly. And so we're going to have to create an IAM role that it can use to when it starts up and it runs. And so we're going to create an IAM role just for our AWS load balancer controller. And we're going to use a new dependency here, the JSON package in Python. And then I'm going to copy and paste this because I am not very conscious that we are kind of like time is kind of getting away from us here. So I'm just going to copy and paste this. And then I'm going to talk a little bit about what's happening here. So we're creating a variable called IAM role. We're using the aws.iam.role resource to create an IAM role. And then what we're doing is we're passing the two values that we have gotten in our stack reference, these two values, we're passing them into our AWS policy. And what's really, really important to note here is that these values here, these two variables here that we're using, Pulumi knows that they are values that it will eventually know, but is not like known immediately at runtime. So what I mean by that is when Pulumi starts, is it's going to grab these values from this other stack, and it needs to make sure that before it tries to build this JSON object here, it needs to be sure that it actually has these values first. And the way that we do that in Pulumi is we use something called an apply. An apply is a wrapping mechanism that basically says, wait until I know this value to do anything inside this apply. It's like an invention. If you are familiar with JavaScript, it's basically the equivalent of a promise. And this is really, really important for us to be able to actually kind of mix and match values inside like standard strings. So we've defined our IAM role, and then there's a couple of things that we need to do. I'm going to just use variables here. So I'm going to define an NS variable called AWS LB controller. And then I'm also going to kind of do some interpolation here to populate this value. And if you are wondering what I'm doing here, I'm using IAM role for service accounts, which is a Kubernetes feature in Amazon EKS, to allow the workload that's running in Kubernetes to access IAM without actually having to have any credentials like an AWS access key and an AWS secret key. So if you are a little bit confused about what's going on here, then please do reach out to me in the Slack after the workshop, and I can quite happily talk a little bit more about this there. But this is important so that when we start up our AWS load balancer controller, it needs to be able to actually talk to AWS and like use this role. And so that's what we're defining here. Okay, so the next thing that we need to do with our AWS load balancer controller's role is we need to say what it's allowed to do, right? So right now what we're saying is that this is allowed to actually call the AWS API and use IAM credentials, but we also need to say what values it's allowed to do. Really handily for us, the people who make the AWS load balancer controller have defined a policy for us. It's available on GitHub. So instead of having to copy and paste all of this calling, it's hundreds of lines of JSON policy object. Because we're using a real programming language, we can just use a standard kind of Python call to actually grab this and populate our Amazon role with it. So I am going to create a new directory inside this thing called files, and then I'm going to download this JSON policy here and store it in this files directory. So you can see here I have an IAM policy with all of the content in JSON inside the project. And then I can use a standard Python open statement that allows us to just directly talk and populate our IAM policy right into our policy object. So again, I'm copy and pasting here. But what I'm saying is open the file, open the JSON IAM policy JSON file, read it into a variable called policy doc, and then populate a new resource called AWS IAM policy, and then populate it with the content of that file. This is one of the great benefits of using a real programming language. I don't need to kind of create a new provider or kind of copy and paste a bunch of stuff. I can just reference this file directly and kind of take care of doing this like without actually having to kind of create a new mechanism to do it. If I was feeling really brave, I could just do a Python requests call to download this file as well. But I think that's a little bit, a bit more advanced. But hopefully it does show you some of the capabilities that you're allowed, that you can kind of do. Next up, we need to make sure that this policy has been attached to this role. And so they're currently two resources and they don't know about each other. So AWS, so the Pulumi provider, has a what we call a policy attachment resource, which basically allows us to say, take the policy we just created from that static file and put it into the role that we created earlier. So again, I'm going to copy and paste this, and then I'll quickly talk through it. So I'm creating an AWS IAM policy attachment. I'm not using a variable here because I don't need to use this again later, right? So I'm just defining this inline in the code. I'm not doing policy attachment equals because I don't need to use any of the values from this policy attachment. So I'm just going to remove that. I don't actually need them. And then this takes a few parameters, the policy ARN, which we are going to grab from here. Policy ARN. And then we're also going to make sure we grab the role, which is, again, an output from the role. So this policy attachment is going to take dependencies from both the IAM role and the policy. And so what Pulumi now knows is that I need to have the policy and the role both be created before I do the policy attachment. So it's creating this dependency graph between different resources. So that's what I need to kind of create my IAM role. And I can now run Pulumi up on this. And it doesn't know about, oh, that's why I've added. So I'm getting an error here, and it's saying it doesn't know what my stack is. And I noticed that I've left this $sign in here. So I just need to remove that because we don't need a $sign in there. So that's what you get when you don't copy and paste. So there is no stack called $dev, and Pulumi is letting us know there is no stack called $dev. And that's just, again, because I just made a mistake when I was doing my my creation there. So I'm going to run Pulumi up. And you can see, look, it's reading the stack reference. It's reading the values from the other Pulumi project, and I can hit details, and you can see it's creating these, like this long list of stuff. But look, the value in one of these things is being pulled from the other Pulumi project. So I can now create new resources with values from another Pulumi project. This is what a platform looks like to your software developers. They are able to just grab API values via stack references, and they can do things in the language that they choose. They don't have to kind of think about learning a new language or learning a new thing to kind of get things done. They can use TypeScript if they're familiar with that, or Go, or anything along those lines. So, we're already starting to make something that's very, very user-friendly for people who just are used to, APIs and people who are used to kind of languages. This is really, really friendly for them. Okay. What we want to do now is we want to create the actual Kubernetes resources inside this Pulumi project. And in order to do that, we need to know what the kubectl access is from the workshop cluster. So when we created the workshop cluster, it created a kubectl API interaction mechanism. And so we can grab that from the original stack. So I'm going to do kubeconfig equals cluster.get output, grab the kubeconfig. And we can then pass that to what we call a provider. One of my favorite things about Pulumi, which I am not going to go into a great amount of detail right now, but if you are interested in hearing about it, let me know in the Slack afterwards. But Pulumi allows you to specify a provider in Pulumi is a resource inside the Pulumi program. So you can pass you don't need to have a global provider for a Pulumi program. You don't need to just have one. If you are familiar with Terraform, you'll know that Pulumi, Terraform applies usually take a single provider. You can specify the provider for each resource that you define. And so what we're going to do is we're going to create a Kubernetes provider that uses the kubeconfig that we've grabbed from the cluster. when we created the cluster stack. And again, if you are thinking about this in terms of like how this is useful for a kind of platform kind of mechanism, you can think about it in this way. Your software developers no longer actually need to know what the how to grab a kube config. They just need to grab it as an API thing. You can wrap all this up in kind of like a software library that they can just use. And some of our big customers actually do this. This is a very, very common thing if you're kind of creating a platform. So we've kind of grabbed our provider. So we know how to interact with our Kubernetes cluster now within this program. Now we want to create a Kubernetes namespace for this AWS load balancer controller to live in. I'm going to copy and paste this because of the time constraints, but I'm creating a namespace using the Kubernetes Pulumi SDK, and I'm going to give it a name, which is this name up here, this NS name, AWS LB controller. And then you'll notice I'm passing my provider I'm passing my provider to this namespace. So I'm saying when you create this resource, when you create this namespace resource, make sure you use this particular access to actually talk to the Kubernetes cluster. And this is configurable. So you can do, if you imagine, like you can do you can create namespace in multiple different clusters if you created multiple different providers from within one Pulumi program, which is really, really powerful. Okay. Time is getting on, so I'm going to have to speed up, unfortunately. The next thing that I need to do is create a service account, which is a Kubernetes construct, which allows us to, talk about, like kind of interact with the permissions model of Kubernetes. And when we created this IAM role here, this IAM role earlier, we now need to pass this down to our service account so that when the Kubernetes controller starts up, the load balancer controller starts up, it will start up and say, I am allowed to talk to the AWS IAM API, and this is the role that I want to use. So I'm going to define this service account. We're again using our apply from earlier because we don't know what the ARN of the IAM role is yet. And so we need to make sure that we tell Pulumi, do not create this a service account until we know what the IAM role is. Don't do it yet. So we're doing it within an apply because we're passing this value into this string here. And so we're using an apply to do that. And then this will allow us to create two really, really important resources. But we also actually need to install the AWS load balancer controller as well. Like we actually need to run that thing. We've only got a namespace and a service account right now. So I'm going to grab a couple more outputs from our original program. I'm going to do cluster name equals cluster.get output cluster name from the first stack. And then I'm going to grab the VPC ID equals cluster.get output VPC ID. Okay. There we go. So we grabbed a couple more outputs there, and now I can pass those outputs to a Helm chart. If you are familiar with Kubernetes, you'll be familiar with what a Helm chart is. But we, the wonderful folks who make the AWS load balancer controller, have created a Helm chart for us. We can define everything manually if we wanted to. We could do all of the different resources in the AWS load balancer controller. We could do it all manually, but that would take a long, long time. Someone's already taken care of kind of defining a Helm chart for us. Pulumi can use Helm charts directly. And so you'll see I'm using I'm using a Helm chart. I'm creating a load balancer Helm chart. I'm going to grab it from the EKS charts repo. I can specify the namespace that I want to install it to. So here, there's namespace.metadata.name, which is coming from this namespace here. I've just noticed a typo in this, so make sure you kind of fix that the region is US West 2. We are referencing the service account that we created. And then we're also going to reference the cluster name and the VPC ID from up here. So these two values here, we're going to grab those from the first stack and pass them all the way through to our Helm chart, which allows us to kind of like create this dependency tree as well. And then the final thing that I want to do before we run anything here is that while the wonderful people at Amazon Web Services have created a Helm chart for us, unfortunately, there is a bug in the Helm chart, which somebody opened a pull request for me today to fix. But it's not fixed yet, right? And so if you are familiar with Kubernetes and you used Helm before, there's sometimes things in Helm charts that you want to manipulate. There's sometimes things you want to change. Pulumi allows you to do this using something called a transformation. And what a transformation is it's a function that you pass to the Helm chart that manipulates the object that's created. So I'm going to define a function called remove status, which takes an object and some options. And then I'm going to say if the object, which is the Helm chart itself, has something in it called, it has a field in it with kind equals custom resource definition. And if you don't know what this is, then please don't feel like spooked. This was a bug that I found earlier. And so what I'm going to do is I'm going to delete from that object anything that says the status. And the reason that I'm doing this is because like there is a bug in the Helm chart, and I could patch it. I can just kind of fix it on the fly when I'm kind of doing this Helm chart. I don't know of any other tool that can do this. Like you can manipulate these Kubernetes objects on the fly when you're running your Pulumi program. It's really, really powerful. And if you are kind of familiar with Kubernetes, you'll know that you kind of have to do YAML templating and all that kind of stuff. With Pulumi, you can do it all with standard, kind of programming language constructs. So I'm going to say the transformations that I'm going to do are run this particular function, this remove status function. And now we are ready. We now have a working Helm chart that will remove the status, broken status field from our Helm chart, and it should provision. So in 100, just over 110 lines of code, we have provisioned an IAM role, an IAM policy attachment, which is all here. We've created a Kubernetes namespace, a Kubernetes service account, which uses the IAM role from before. And then we've also used the Helm chart that has already been defined. We've patched that Helm chart, and we are going to run all of this against our Kubernetes cluster. I knew this was ambitious when I put this together to kind of do this in 2 hours, and I realize I have gone very, very quickly through this. And I've done that for a reason, because there's even a third stage that I kind of want to get through to make sure that we can kind of like see some of the power of Pulumi. If you do feel like this is too fast, then please let us know. If you feel like it was just the right speed, let us know. But I am aware that I'm kind of motoring through a lot of the content here. So, and there's a lot of advanced concepts that we're talking about. So let's provision our load balancing controller. I'm going to run Pulumi up against this project. And you will see it's going to provision quite a few resources. So it's creating our namespace, which we created. It's creating our service account. We already created all of our IAM roles in a previous Pulumi up. There's a couple of warnings here, which is basically telling me that in future versions of Kubernetes, the thing that's in the Helm chart is no longer going to be supported. But it's just like it's just a warning that's just telling me, eventually you're not going to be able to use this. But because we're because we're using an older version of the Kubernetes in the EKS cluster, it's just letting us know that we want to patch this at some point later. If I really wanted to, I could use a transformation to fix some of these things. So you'll notice it's saying that it's moving from V1 beta 1 to V1. I could patch these things with a transformation, which is super powerful. I would no longer have to go and kind of modify the Helm chart. I could just patch it myself. But let's run this. Let it create our resources inside Kubernetes. Give it a second while it's creating the Helm chart and installing all this stuff for us. Pulumi's Kubernetes support, in my opinion, is a first-class citizen. It is one of the best features about Pulumi, in my opinion. I've been using Kubernetes a long, long time, and in my opinion, it's the best mechanism for interacting with Kubernetes. It has so many exciting features like waiting for things to be ready and like state health checks and all that kind of stuff. So you can do all kinds of exciting stuff like around blue-green testing. But in the space of in the time I've been talking, it's created our AWS load balancer controller. So we should be able to interact with our Kubernetes cluster and see what is happening. So let's do kubectl get namespace AWS LB controller. So our Kubernetes namespace is active. It's been created. We want to get the logs from a resource that's running in that namespace. So I'm going to do kubectl logs in the namespace AWS LB controller. And I want to get all of the logs for an application with the label with two labels. One is app equals AWS LB controller, and one is the stack equals dev. And we added these here. So I added the stack that we're currently in, which is dev, and I added an application label called AWS LB controller. So I should be able to run that. And we get a bunch of logs saying that our AWS load balancer controller has started up. And so if you've ever run a Kubernetes cluster, you now know that we have this load balancer controller. We can now provision application load balancers and network load balancers within this Kubernetes cluster. So, we are ready to kind of move on to what I believe is the most exciting part of this particular workshop. So I'm going to take a pause there. If anybody is still following along, I realize I've gone very, very fast. Please let me know please let us know in the chat. But then the final thing that I'm going to do is I'm going to provision a very, very small application to this cluster, but I'm going to do it without actually writing a single line of Pulumi code. And I'll show you how in just a second. Okay, so I'm an infrastructure engineer. I've created a Kubernetes cluster. Hypothetically, I've created a Kubernetes cluster, and now I want my software developers to be able to use it, right? In most circumstances, in most environments, they're either going to have to do one of three things. They're going to have to learn how to create YAML files that match Kubernetes, right? Which is a learning curve. It's a learning experience for them. Or they're going to have to learn Pulumi and learn how Pulumi talks to, Kubernetes. And that's another learning curve. The third option is that they give it to you and you do it for them. And in my experience, when you ask people to do one or two, they will usually do three. And I kind of ran into this throughout my time running a Kubernetes platform, where I was constantly in this situation where people, I would say, you're going to deploy this to Kubernetes. Here's an example. Make the example work for you. And it would be this backwards and forwards between how the YAML works and all that kind of stuff. So what I'm going to do here is I'm going to create an example application called platform app. And I'm going to make a small Go application that is like a web server. So if you just suspend your belief for a few seconds and imagine that this is a much more elaborate application inside a production kind of organization, and they want to deploy to Kubernetes, right? But I'm going to just do a very, very simple Go application here called Hello World. And you can see here, I'm just spinning up a web server, and it will just return Hello World. I'm going to be a little bit more, I'm going to say Hello Lee. And so I'm going to kind of create this Go application. And because it's Go, I can run this locally and all that kind of stuff. But what I actually want to do, if I'm going to run it in Kubernetes, I want to put it in a Docker container, right? So I've created a Docker file, like so. And this is my Docker file. So I'm going to use Docker to build my application. And I could run this locally as a Docker container and build it. You can see here there's two stages to this Docker file. There is one which actually builds a Go binary, and then it passes it to a second container, which is the actual thing that will run inside the Kubernetes cluster. And so, this is the situation that a lot of people in software development organizations are in, right? They want to, I have an application, it's in a Docker container, like you asked me to put it in. Now, how do I get it to my Kubernetes cluster or your Kubernetes cluster? And in a lot of situations, it's really, really hard for them to kind of go through the learning curve of understanding how Kubernetes works and building YAML documents and then all that kind of stuff, right? And so I wanted to come up with a mechanism that would allow anybody who has a Docker container to run on a Kubernetes cluster. And the way that I did that is using a new Pulumi feature, which we call the Automation API. And what that allows you to do is build applications that use Pulumi, but you don't have to write any Pulumi code at all. Like the end user doesn't actually have to write any Pulumi code at all. And so I've created this. It's available on GitHub if you want to take a look. It's available. Let me bring up the screen real quick. GitHub. It's called Ploy, and I'll place a link in the handouts at the end. But this is the GitHub application. Anybody can use this right now. It's available for you to use in whatever way you kind of want. And what this is doing is it's creating a Pulumi program inside a Go binary, right? And so you can see here, I'm looking through the code. You can see this is using our Go SDK. So we're creating an ECR repository to store our Pulumi application, to store our Docker container. And then we're also going to build a Docker image, here. And then we're going to create a Kubernetes namespace for our application and a deployment and a Kubernetes service so that we can actually access the thing. And so this is all wrapped up inside a binary, so the end user itself never actually has to interact with Pulumi at all. It's still going to use Pulumi in the background, but you as an end user never have to write a line of Pulumi code. So I'm going to clone this repo here. I'm going to go up a directory, do git clone, and we're just going to, okay, there we go. And then I'm going to go into the directory, and I'm going to see, you can see it's just the same thing. And then I did just remember that one of the things that we what we can do here is because some of these things, some of these instances, they have a bunch of already set up stuff and they run out of disk space. Just to save some time, you can clone that and you can build it yourself using Go build. But I'm actually going to recommend that we follow, that we kind of look at, if you look at build platform binary here, I'm actually going to recommend that you download this from the website that I've already created it, because it will, there's a good chance that it will take a little while for it to run, and we're running out of time, unfortunately. And I wanted to leave some time at the end for some questions. So what I'm going to do is I'm going to download it. Using curl. And I need to actually... And then I'm going to unzip it. Like so. And you can see in this tarball, we could also do a Go build, and we could build this locally. But if you imagine the experience for a developer, you could kind of package this up and just kind of include it on developer laptops, or have a homebrew binary or something like that. So I have this binary available. I'm going to make it executable. X. And then I'm going to do what we did earlier with the kubectl binary, and I'm going to move it into our path. And so I should be able to run ploy now. And you can see I now have an application that's ready to go. It's ready to kind of do some stuff. And so what I'm going to do is I'm going to go back into my platform app here. Like so. So I've got a Docker file that's going to build from our main.go. I just realized I missed a step. Yep. So I'm going to, I want to deploy this. I'm a software developer, and I want to get this to my Kubernetes cluster, and I want to do it as quickly as possible. Well, with the Pulumi Automation API, this is how that would go. You would run ploy, you would run up, and then you would specify an organization, a Pulumi organization. This is the only required field. And what I can actually do is I can create a config file that does that for me. But in this particular case, I'm going to deploy up and specify an organization, which is my Pulumi organization, Jack Storm. I'm going to hit enter. And you can see it's creating an application for me. It's creating an ECR repository. It's creating a Docker image. It's creating a Kubernetes namespace. It's doing all of this for me, and I'm not having to do anything at all. And I can show you in the background what's happening. Like, I haven't written a single line of code here, Pulumi code. But if I go into here, you see it's creating my Pulumi application. It's happening nicely. Eagle Lion is being created. I lost my page. Nicely Eagle Lion is being created. You can see there's an activity going on here. If I look at the update, you can see the changes that are being made. And it's told me that there's no space left on the device, which is something that I should have expected. So let me fix that real quick. I'm going to kill that. And then I'm going to Docker RMI, Docker images. And now I have some spare space. So let's try that again, shall we? Let's do ploy up minus O. And it's going to create a new wildly welcome calf in this particular case. You can see, like, I can see in my Pulumi console that there was a problem. So let's have a look at wildly welcome calf and see if that's doing better. The reason that I ran out of space on the Cloud9 instance is because it's trying to build the Docker container locally to push it up to the ECR repository. And one of the things that happens if obviously when you're building this Docker image, it's running out of space basically locally. So we're creating wildly welcome calf. It's creating my ploy deployment. It's creating my Docker image. It's creating my Kubernetes deployment. And again, like, you've got to imagine somebody who has no experience with Kubernetes, you can just pass them this binary and it's creating it. So and now it's telling me my service is available at this address here. So let's do. It's just going to take a moment for the DNS to resolve. So currently it can't resolve the host, which is, again, it's just something that's happened on the AWS side. So it's deployed this. By default, Ploy will use like a standard Kubernetes resource. Earlier on, I added support for our load balancer control that we specified. So I'm going to do Ploy up minus O, my organization, and then specify that I want to use an NLB, which will use our load balancer controller. So I'm going to do that while we wait for DNS to register. And again, it's going to create a new application. Wildly welcome calf is there. Routinely game stud is there. And it's created our AWS load balancer. So I can use my logs command from earlier. And you can see the fruits of our labor have been paid off. It created a load balancer directly for our routinely game stud deployment with an NLB. And so I should be able to, not that one, because that's still going to take a little while. And there we are. My Kubernetes deployment happened with Pulumi in the background with no interaction from the me as the end user. I didn't have to write a single line of Pulumi code. This is what the power of the automation API gives you. It gives you this ability to create a best practice for your organization. And I can actually look at my getpods namespace is, what did we call it? Routinely game stud. I've enforced this best practice with Pulumi to my end users. I've said I want a minimum of 3 of these running, right? And I've enforced this without actually having to write any Pulumi code at all. Like, I've built it all in. I've abstracted all of this away from my users. I am going to destroy this one now. Destroy that. We take a look at our Pulumi console. You'll see here, it should any minute now. You should see there's something running here. And it will be disappearing any minute now. Routinely game stud is what it was, the stack that it was. Destroyer started. again, like this is so powerful for anybody who's trying to build like a set of best practices. And then I'm finally going to destroy this one. Again, this is an example of the automation API. I have done something here. I've created a Pulumi program that interacts mainly with, I've created a Pulumi program that interacts with Kubernetes. You can do this in whatever the provider you think is best. So there's no kind of limits to what you can build. We currently have the automation API available in Go, and it's available in TypeScript. And we should have the other languages coming very, very soon. So that's everything today. I do completely understand that we've been through a lot of content, and in a lot of cases, we haven't really kind of dug in as much as I would have liked, simply because we have time constraints. So I do appreciate everybody's patience. And if you weren't able to follow along, I do hope that you got a lot of value out of kind of listening to me talk, even as a minimum. I'm going to stop sharing my screen right now and then kind of go back to the slides so we can just finish up and make sure that everybody we talk about what we've been through. So back to the slides. What did we learn today? We provisioned an EKS cluster. We created it from the Pulumi crosswalk library, which is, again, an example of what you can build. If you want to build NPM packages or Python packages or Go modules that you can consume within your organization, you can do the same thing. We used AWS Crosswalk for Pulumi AWS Crosswalk. You can use whatever you like. And we then deployed a Kubernetes workload using a Helm chart, and we used that directly within. We used that to directly interact with. We use that to directly interact with AWS resources. So in a lot of examples, you would need to do a Kubernetes cluster and a bunch of AWS resources, and you probably need to use two different tools to do that. You might need to use CloudFormation and then Kubernetes YAML. But instead, we had one Pulumi program that did everything for us. And that to me is really, really powerful. It's really, really amazing that you can just kind of no longer have to kind of mix and match tools within your organization. And then finally, we use the Pulumi automation API to abstract all of this away from your end users. So then your end users can provision infrastructure directly without actually having to write a single line of Pulumi code. And we showed you an example, and I would love to see if anybody builds anything with the automation API. I would love to hear about it. Please let me know in the workshops channel. I will very quickly say that there is a example from my wonderful colleague Christian of writing a Electron app with the Pulumi automation API. So he's gone and actually created a local desktop app to provision infrastructure. And this is, again, the power of the automation API. There's nothing like it in the industry. And I'm super excited about what we can do with this. If you liked what you saw today, please join us for other workshops. I think this will be the last one for this year with the Christmas period coming up. I do intend on running more workshops in the next year. If you would like a workshop for your organization tailored to the things that you're doing, we're quite happy to do that. So please reach out to us in the Pulumi Slack, and we can get together and we can talk about doing demonstrations for your organization, or kind of doing workshops where we can do guided tours through things for your organization. So please feel free to join us for that. We have offline workshops. So if you take a look in the handouts tab, there is the Pulumi.aws workshop link, which we were following along with earlier. There is 3 other workshops there at the moment with a whole bunch of other content where you can follow along. If you just want to get started with Pulumi, there's 2 great resources for you. There's the Get Started page, which will give you lots of small guided examples. And then if you actually just want to kind of get started building stuff, there's the examples repository in GitHub, which are, again, available under github.com Pulumi. And there's loads of great examples there. So if you are interested in things like Lambda and serverless and API gateway, there's loads of great examples available on GitHub. As I mentioned earlier, everybody on here will get a free account for individuals. If you do want to use things with your team, then sign up to a trial. If you want an extended trial, please reach out to us. We can definitely put extended trials together if you kind of want to build a proof of concept and all that kind of stuff. And then you can share what you learned today with your peers. So sign up in the Pulumi SaaS. Go to the new organizations button, as I showed you earlier, and feel free to kind of like have a look at what you can do. But finally, I would like to thank my wonderful colleague, Zach, who has been here for all of the workshops that we've done, including the introduction workshops. And thank you very much for his help. I'd like to thank Andrew and Young and Yaniv from AWS for kindly providing the resources to allow you to follow along. Please give us feedback. We do want to make sure that people come out of these workshops with value and they feel like they're actually learning things. So please let us know what worked for you and what didn't work for you. There is a poll coming out now where you will be able to rate out of 5 what you think of this. If you have more feedback, then please let us know. We'd love to hear more from you. It's really, I'm really excited about what we're building here at Pulumi, and I hope you are too. I will take my leave now. I'm going to turn off the webcam and the microphone. I do appreciate the great feedback that I'm getting from everybody. This is fantastic. If you would like more, again, please let us know. To answer the question that just came into the Slack, yes, you can just look at the content online. If you have your own AWS account, then follow along. If you get stuck, there is the workshops channel in Slack. Join there, and we can help you kind of, learn more stuff. Thank you very much, everybody. I hope I saw that we had people from all around the world. So wherever you are, good evening, good afternoon, or good morning. But thank you very much for joining us.